Applications of right triangles. Angle of elevation is the angle between the horizontal, so this is the horizontal, and the line of sight when the object is above the horizontal. So this angle right here is angle of elevation. If someone from here observes an object up in the air, the angle of elevation will be this angle right here. Angle of depression then is basically if the observer is up here and he or she is observing something on the ground, the angle it makes with his eye and the sight line, which will be the then angle of depression. So this is angle of depression and this is angle of elevation. Elevation is when you are on ground looking something up. Depression is when you are up and looking something down on the ground, for example. Let's look at some examples. In designing a new building, a doorway is 83 centimeters above the ground. A ramp for wheelchairs at an angle of 7.1 degree with the ground is to be built to the doorway. How long is the ramp? So to begin this problem, we'll start with sketching the triangle. We'll start with sketching the graph here. So in this particular example, we have doorway which is 83 centimeters above the ground. So this right here is 83. Okay. And the angle of elevation, the angle it has to be built with ground. So that's angle of elevation. That will be right here. And that will be 7.1 degrees. This will be 90 degree. And how long is the ramp? So this is our unknown. Let's call it x. Now using SOHCAHTOA, depending on the situation, we'll either use sine, cos or tan. In this case, because we know opposite and we want to find hypotenuse, we will say sine theta equals opposite over hypotenuse. In our case, we will say sine theta, which is actually sine 7.1 degree. So sine 7.1 degree equals opposite is 83, hypotenuse is unknown. Cross multiplying, we get x equals 83 divided by sine 7.1 degree. Then we will get x equals 83 divided by sine 7.1 degrees. We will get 671.51. So it will be 671.51 centimeter. And that's what we will have. A brush fire is 75 meters away from the base of a tower. A brush fire is observed at angle of depression of 5.8 degrees from the observation level. What is the vertical distance between the plane level and the observation level of the tower? So basically the height of the tower. So let's quickly sketch this. So let's say this is our tower and here is someone observing. The brush fire is somewhere here, let's say. Okay, so that should be a right angle triangle. So let's make it a little bit better. So it should go something like this. So the angle this person is observing is this angle right here, which is 5.8 degrees. Using the Z pattern, whatever angle is here, this angle right here has to be same. So this will be 5.8 degrees. This is the one we want to find. Distance between, or vertical distance between plane ground to the observation deck. And we are told the brush fire is 75 meters away from the base of the tower. So that is this distance right here. Now for this situation, we are given adjacent and we want to find opposite. So the one which connects adjacent and opposite is tan theta, which is opposite over adjacent. So in our case, tan 5.8 degree equals opposite is x, adjacent is 75. Cross multiplying, we get x equals 75 tan 5.8 degrees, which then will give us x to be 75 times tan 5.8 degree, which will then be 7.62, roughly 7.62 meters. Okay, That will be the height of that tower. Now if you notice, 7.68 is very small number compared to this 75 meters. The diagram is not proportionate. 5.8 degrees very tiny angle. So this length will be long length. So that's why 75 meter versus the height should be very small. Now one more thing to notice is the angle we have is here is 5.8. So this will be 74.2 degrees or 84.2 degrees. Opposite of larger angle should be the longer length. Opposite of very small angle should be very small length. So 7.62 seems reasonable there. Now let's see some more problems here. Let's say we want to try this problem right here. The street light is designed as shown above, so below. So we are given this diagram here. How far above the street is the light? So we want to find out distance from here till here. So let's see how we will do that. So for this one, basically we want to find distance from here to here. This is all we want to find. We already know this one is 7.95. So if we can find this and then add this distance, we will find the total height, how far above the street is the light. So we can find that. So let's start with finding x first. So respect to 30 degrees, x is opposite and we are given hypotenuse. So the one which connects opposite and hypotenuse is sine theta. So we will say sine theta equals O over hypotenuse. In our case then, sine 30 degrees, which is half, equals opposite is x divided by 3.14. So then x will be 3.14 sine 30 degrees. So half of 3.14 will be 1.57 or actually 1.57 and that is in meters. So now that we have this to be 1.57 meters, the total height will be then x plus 7.95. So we will have that to be then 1.57 plus 7.95. We will get h equals 9.52 meters it will be. Okay, let's see one more here. Let's say we have something like this. A search and a rescue helicopter locate a ship in distress at 18-degree angle of depression. If the helicopter is flying at an altitude of 975 meters, find the horizontal distance between helicopter and the ship. So for that one, let's sketch the scenario here. So we have a helicopter somewhere here and it looks down and it says angle of, so then this one is the ship here, right here, and then if we were to make a triangle from there, right angle triangle, this is the helicopter, this is the ship. We know that angle of depression here, right here, is 18 degrees. Again, it's not to the scale, it's just a rough sketch. So that is 18 degrees, and the height of the helicopter is 975 meters, and we want to find out this distance x here. So we are given opposite, we want to find adjacent. So the one which connects opposite and adjacent is 10. So tan theta is O over A. In our case then, tan 18 degrees equals 975 divided by x. Cross multiplying, we get x equals 975 divided by tan 18 degrees. So x will be then, so 975 divided by tan 18 degrees, we get 3000.74. We get 3000.74. So it's roughly 3 kilometers away. Okay, and this, because this is in meters, so we can then say the horizontal distance between the plane, between the helicopter, and the ship. The ship is about 3 kilometers or 3000 meters. Okay.